great having you on this platform. JAMB past question 2001, question number 26. A student is at a height 4 meters above the ground during a thunderstorm. Given that the potential difference between the thundercloud and the ground is 10 raised to the power 7 volts, the electric field created by the storm X. Our question here is highly centered on electric field. To do justice to this question, let's get out the parameters. Solution. Okay. So we had height 4 meters. We also had potential difference, PD, or voltage, 10 raised to the power 7 volts. Then the electric field created by the storm, we're looking for electric field. We use capital letter E to represent electric field. Question mark. Okay, these are the basic parameters in our question. We have height, voltage or potential difference, and electric field intensity or electric field. Okay, if you have a good understanding of your electric force, Coulomb's electric force, you'll be very much aware that there is a connection between potential difference or the voltage and the electric field intensity or electric field. The potential difference is proportional, directly proportional to the electric field or electric field intensity. And the proportionality constant there is radius or height. What am I saying? I'm saying that V is directly proportional to E. This potential difference, this electric field. Therefore, V is equal to Ke. Then V is equal to this K. The constant there is a height or radius. Height or radius. Okay, let me use R here. Then E. To put this formula better, I'll be having V is equal to ER. I have a simple way of saying this formula. I call it VAR. VAR. Even though I know it's VAR, but what I have in mind is VAR. VAR, but I know it's this. So that can be your a kind of easy way of remembering this formula. In electricity, there is a formula called VAR. So what we mean there is VER, where V stands for voltage or potential difference, E for electric field intensity, and R for radius or the gap between two charges, or height. Distance, radius, height, all are measured in the same units, meters. Okay. Okay, let's put this aside. So using the main formula VAR, let's go back to our question. The height is the radius, the gap between two charges. Okay? Then we are looking for electric field intensity. Electric field intensity, make it the subject. E becomes equal to V over R. Dividing both sides by R. I'll be having E is equal to, my voltage is 10 raised to the power 7 over my height or radius is 4 meters. Then when you divide that, you'll be having E is equal to 2.5 times 10 raised to the power 6. Okay, observe the unit of voltage. Okay, Newton per coulombs. Newton per coulombs. Okay, electric field can either be measured as volts per meter or Newton per coulombs. Why? Because there's another formula that says F is equal to QE, where F stands for electric force, Q for charge, E for electric field. Making electric field the subject, we'll be having F over Q. And that's what led to Newton per coulombs. Unit of force is Newton per over unit of charge, coulombs. So it's either you measure electric field or electric field intensity in Newton per coulombs or volts per meter. Either can go. Please stay tuned as we push ahead. Observing the best option there is option B.